The I-code area. Also called the instruction area, this is the first major section of an I-code module and contains all of the instructions to be processed by the runtime module, runb, or by Basic09 if the procedure is small enough to load into Basic09's workspace. The default workspace size in Level 1 is 4K. In Level 2 it's 8K. In Level 1, you can increase the workspace size to 32K using the command line memory modifier on the OS9 prompt. Basic09 #32K. Under Level 2 you can increase the workspace size to 40K using the same memory modifier syntax. Basic09 #40K. The command line memory modifier also works with runb. You can also increase the size from inside Basic09 using the mem command. In Level 2 you can only increase the workspace size to 32K maximum using the internal mem command. Each instruction is converted from infix notation, the source code form, to postfix notation when the source code is loaded into Basic09. For example, the source instruction a equals a plus 1 is converted to the tokenized form a equals a1 plus. In the I-code module Basic09 creates when loading the source code file. Dimension statements, type, dim, dimension, and param, parameter, can be placed anywhere in the source code listing. These program variables are compiled at loading and are placed in the symbol table and description area as they are found by the compiler. In unpacked modules, these statements are kept in the I-code area to allow modification. In packed modules, these statements, as well as any comment statements, are removed. Variable references are organized by Basic09 in the order of occurrence in the statements, but in data memory are stored dimensions first, followed by named subroutines, followed by parameters. Variable references will be covered more in the symbol table and description area videos. In I-code all variable and line references are denoted with 3 byte structures using the form token, byte, followed by offset, integer. What follows here are descriptions of the various types of instructions using keywords, such as loops and conditional statements. You can see in the web document how these statements are constructed: source statement first, I-code result second, text interpretation of the various tokenized parts of the statement third. The seek statement shows one of the peculiarities of I-code, in that the size function has 2 tokens instead of just 1. The first token, hexadecimal 94, is the actual function token, even though it is placed after the variable reference, and the second token, hexadecimal 95, is placed before the variable reference. The only other function with this peculiarity is the address function, addr. You can see in the web document the various file access mode tokens in Basic09. Update is the default mode, so you don't have to specify a mode if you want to use update mode. In essence, open #path, filename is the same thing as open #path, filename, :update. In the web document, the data memory map shows how data memory is organized in I-code modules. The for next loop construct has the most complicated structure of all of the loop constructs. The integer value after the to keyword indicates a data memory location, and while not shown in the web document, a step keyword is also followed by an integer value representing a data memory location. Following the to memory offset and the step memory offset are numeric literals, constants, containing the value to assign to them. I have never tried it, but I believe you can specify variables instead of numeric constants. The next statement has 3 fields and an invisible goto. The 3 fields are a byte to determine if the loop is integer-based or real-based, and whether or not there is a step value. An integer pointing to the data memory address of the variable after the for keyword. An integer pointing to the data memory address of the to variable. An integer pointing to the data memory address of the step variable, 0 if there is no step value. The invisible goto points to the first instruction inside the loop. This is the only use of invisible goto that does not use the hexadecimal 55 token. The while loop construct tests an expression at the beginning of the loop. The web document shows an example using a test for the file pointer not being at the end of the file, and executing everything between the while statement and the end while statement if the result is true. The end while statement contains an offset address that points to the while statement. When the test fails, result is false, The invisible goto in the while statement points to the first byte after the end while statement. The repeat until loop construct is the opposite of the while end while loop. All instructions between the repeat statement and the until statement are executed before the expression in the until statement is tested. The invisible goto in the until statement points to the first instruction after the repeat token, and if the test results in false, will return execution to that instruction. The loop end loop construct is the most simple loop of all. There is no exit from this loop without using the exit if and exit conditional construct. The end loop statement contains an offset address pointing to the first statement inside the loop. This video ends here. The next video continues the I-code area with the conditional constructs. Thanks for watching, and I'll see you in the next video. Please press that thumbs up if you like the video and believe you have gained something from it.